A matrix is simply a rectangular array. Okay. Each element of this array, such as this A22, AM3, are represented as Aij. Okay, where I is the row ID and J is the column ID. Okay, the values of I and J do have a range. Since we have n columns and m rows, our value of I is in between 1 to m, and the value of j is always between 1 to n. Okay, so now we have m rows and n columns. We can then define the size of our matrix A to be m cross n. Okay, where, to repeat again, m is our number of rows and n is the number of columns. Okay, now based on this case, let's consider a couple special cases. The first one, let's say our m, which is the number of rows, is equal to 1 and n is not equal to 1. Okay, so that will give us only one row in a matrix, and we will call that a row vector. Okay, let's call that row vector R. Then we can write row vector as R11, R12, R13 up to R1n. Since it is redundant to write 1 every time, instead of writing R11, we write R1, R2, and Rn. So whenever we see a vector which is in a row form and has only one index, we can say that that is a row vector. Okay, now similar to the previous case, we can now say our m is not allowed a value of 1 while our number of columns is 1. So then we result in a single column in a matrix which is called a column vector. Okay, let's represent this vector by C, and similar to the row vector, we'll end up with components such as C1, C2, C3 all the way up to Cm, where m is the number of rows.